Okay, so in this video, we're going to look at similarity. We're going to define it and do some examples. So similar figures are the same shape, but different sizes. The angles are congruent and the sides are proportional. Okay, so these are two triangles that are similar. Okay, so what we notice is angle F is the same as angle A. Angle E is the same as angle B. If two angles in this triangle are congruent to two angles in this triangle, these third angles also have to be congruent since both of the triangles add up to 180. So to get this angle, you would do 180 minus this. And since these are the same, you'd get the same exact value for angle C. So these angles are congruent. The sides are proportional. So what that means is they are increased or decreased by the same scale factor. So if I want to check it, what you do is you divide the sides to figure out the scale factor. And if they're all the same, then the sides are proportional. Now, when you match them up, you match small side with small, medium with medium, large with large. So don't just go by the orientation. So like 2 doesn't go with 6. 2 is the smallest side on this one because you have 2, 3, 4. So choose the smallest number on this one. 4 is the smallest because 4 is smaller than 6 and 8. So it doesn't matter which triangle you put on top, just be consistent. So I'm gonna do the bigger one on top. So I would do 4 divided by 2, which is 2. And then I would check the next side. So I would have 3, which is the medium side. So this is small, medium, large. This is small, medium, large. So then I would do 6, which is the medium with the medium of the other triangle. And that's also 2. And then I do the same thing with a large. 8 divided by 4 is 2. And so the scale factor is all the same. So that means the sides are all proportional because for each of these sides, you would multiply by 2 to get this side. And so they have the same ratio, which is the same proportion. Now, when you do a similarity statement, it's like a congruence statement. You write triangle and then you do any order of the first triangle and then you use this, the tilde. So that means similar. And then you match them up. Okay, so A has 1 mark, so does F. So A goes with F. You can also say, okay, AB is the small and FE is the small, so I have to go that way. So E goes with B because again, there's 2 markings, and it's between the small and the medium, just like over here. And then C would go with D. And so this is the similarity statement. Okay, be very careful. It's really easy to be fast on these and then make a mistake. Okay. So there are 3 ways to prove triangles similar. The first way is angle. If 2 angles of 2 different triangles are congruent, then the triangles are similar. Again, you don't need all 3. If you have all 3, great, but you only need 2 pairs. Then you have side. So if the 3 corresponding sides of 2 triangles are in proportion, then the 2 triangles are similar. To check that, we do this, where we divide all the corresponding sides and see if we get the same ratio, the same value. And then side angle side. So if 2 corresponding sides of 2 triangles are in proportion and the included angles are congruent, then the 2 triangles are similar. So this would look like if I have this, and I have this, and then these are the same ratio. So this is 4 divided by 2 is 2, 6 divided by 3 is 3. So this scale factor would be 2, and this would be side angle side. Okay, so side would look like what we had. So if I have 2, 3, 4, like all of these would be double or triple. So let's say they're all triple. 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. And these would be 2 similar triangles by side. And then angle is just, again, 2 pairs of angles marked congruent. So that would be like angle. Just like congruent triangles, similar triangles should be named so that the corresponding angles and proportional sides line up. Okay, so we're going to do a few examples. We're going to determine if the two triangles are similar, and if so, we state the postulate, which is the similarity. The postulate is these three: angle, angle, side, 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 angle, side. These are all the postulates, the ways to prove. And then this is our similarity statement, which you're going to state both anytime they're similar. So if we look at this, okay, we have 30, 89. We should probably find the third angle. So we can do 180 minus 30 minus 89, and we get 61. Okay, and we can do that here. So 180 minus 91 minus 28 and get 61. So I just, again, did to find angle U, I did 180 minus 30 minus 89, and I got 61. To find angle F, and I'll put the M for the measure. I got 180 minus 28 minus 91, and I got 61. So there is one angle congruent, but the other two are not. They're close, but they're not. So these are not similar. And if they're not similar, you're done. You don't state a postulate. You don't give the similarity statement because they're not similar. Okay, and that's because two of the angles, technically all three of the angles have to be congruent for them to be similar. Okay, so here's another one. Now with these, we use a lot of the parallel line properties. So you're going to see these arrows a lot, which means the lines are parallel. And if the lines are parallel, then you're looking for those angle pairs. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. So you're looking for those. A lot of times it's alternate interior, but that's what you're looking for. So here's my parallel lines, AB and CD. And therefore my transversal, I have two of them. One of them is CB and the other one is AD. Okay, and so we know that this angle here, angle A and angle D, are alternate interior. Like if we just write it like this, we have this pretty much, but they just do it as triangles. So those are alternate interior. And then we also have angle B and angle C, and those are also alternate interior. So, and then we have angle E, which we also know is equal to, I guess, angle AEB and angle CED because they're vertical. So we have all of that. I'm going to write that all out. So angle A is congruent to angle D. Okay, alternate interior. And I have to have the lines parallel. AB is parallel to CD. Okay. And really, we only need two of these, but I'll write them all. So angle B is congruent to angle C, since they are also alternate interior. And AB is parallel to CD. And then I have to name it with 3 letters because angle E could name 4 different angles. So angle AEB is congruent to angle C, well, DEC if I match them up because they are vertical. Okay. And so therefore we have technically angle, angle, angle. We just say angle, angles. So the postulate, the reason that they're congruent is angle, angle. And then the similarity statement, I would have triangle ABE is similar to triangle. Okay, so A went with D, so I'm going to start with D. B went with C because they have the same markings, and then E went with itself. And that's the similarity statement. Okay, so let's look at another example. So I have these two triangles. It says determine if they're similar, and if so, state the postulate in the similarity statement. Okay, so this one I don't have any angles marked congruent, but I do have side lengths. So I'm going to label them small, medium, large. So this is my small, that's the smallest number. Medium, this is the largest. On this one, 5 is the smallest, 6 is the medium, 8 is the large. So when I compare them to find the scale factor, I'm going to match small with small. So I'm going to do 10 divided by 5. The order you do, like whether you put this triangle on top or this one, it doesn't matter. Just be consistent. Most students prefer the larger triangle on top because then they don't have to deal with fractions, which is fine. So then that's the small. The medium would be 12 over 6, which is also 2. And then the large would be 15 over 8, which is not 2. It's 1 point something, 1.875. Okay, and so these sides are not proportional. They're not all being multiplied by the same number to get this triangle. And so these are not similar. And again, if they're not similar, you don't write a postulate, you don't write a similarity statement. Okay, so a few more. Determine if the two triangles are similar. If so, state the postulate and the similarity statement. Okay, this is the hardest one because you need to compare the triangles. So I would redraw them separate. So I have this little triangle ERQ, and most people can see that. This is 48. I don't have this side. Okay, this side I can find. The whole thing is 70. This is 10. So this piece would have to be 70 minus 10, which is 60. And then I have my big triangle because I have to compare triangle to triangle. I can't do this shape, this trapezoid to this triangle, which some students try to do. So this is E, F, G. Okay, this side they told me is 70. To get this side, I can add 48 and 8 and get 56. And then we notice that one of the angles are the same. Angle E is exactly the same angle in both triangles. So I can mark those congruent. Those angles are equal. So now I'm going to compare. Okay, so I have two pairs of sides and an angle in between. I have to check that the sides are proportional by checking the ratio. So again, I'm going to do the larger one, which is 60 and 70, and divide them. Okay, and I get 60 over 70 is 7 over 6. Okay, and then for the other one, I would do 48 over 56. Nope, sorry. I want to flip that. I need to do the large triangle on top. So 56 over 48, and that's a common mistake. So be careful with that. It's always, if I did this one on top, then this one has to go on top. Okay, and if you divide them, I mean, if you do 7 divided by 6, you get 1.66. Usually we do it as a fraction, but if you do this, you also get 1.66. And then if you make that a fraction, it's 7 over 6. Okay, they're both divisible by 8. So 56 divided by 8 is 7, 48 divided by 8 is 6. So those are proportional. And then I have this angle in the middle. So this is an example of side angle side. And then my similarity statement, I'll just start with E. So E, R, Q. Again, the first order doesn't matter, it just matters that you match up. So E goes with E. Okay, I went E to R, which is along the large side. So I want to do the same thing and go to E to F and then to G. And that would be my similarity statement. Okay, they did a different order. So they had E, F, G. They did this big one. And then that would go with triangle E, R, Q. Okay, and then this one is our second one. And if you look at that, we have these two triangles. They have R and A are marked equal. And Q is equal to B. Okay, and so that is two pairs of angles. So this would be, yes, they're similar by angle, angle. And A, B, C would go with, A goes with R, B goes with Q, and C goes with P, and that would be the similarity statement. Okay, so that's different examples of how to apply the postulates and the similarity statement to different triangles. If you have any questions, let me know.